As many of you are probably aware, discriminant analysis and multinomial logistic regression are complicated statistical tests. Each test is appropriate when the dependent outcome is nomial or categorical. The decision to use one test over the other will be dependent on the research question and the independent variables. When we consider the discriminant analysis is a statistical technique used to predict group membership from several predictor variables. The discriminant command in SPSS performs what's known as a canonical linear discriminant analysis, which is the classical form of discriminant analysis. Multinomial logistic regression is a statistical technique used to predict membership in relation to a reference variable value from several predictor variables. And as we move along through the session today, I hope to make that a little bit more clear. When we consider the statistical assumptions of discriminant analysis, the dependent variable should be measured at the nomial level, right? It should be a categorical. The continuous variables, so the independent variables or the predictors, all have to be multivariate, normally distributed for each of the populations or each of the groups. There should be no outliers in this. The population variances and covariances among the dependent variable are the same across all levels of this factor. The participants, of course, are randomly sampled, and the score on a variable for any one participant is independent from the scores of this variable for all other participants, so there's no relationship. And once again, there should be no outliers, no high leverage values, or highly influential points for any of the factors or variables. When we look at the statistical assumptions of multinomial logistic regression, the dependent variable should be measured at the nomial level or categorical level. One or more of the independent variables, they can be continuous, ordinal, or nomial, including dichotomous variables. This is one of the differences between discriminant analysis and multinomial logistic regression. However, ordinal independent variables must be treated as either continuous or categorical. Of course, we also have the independence of observation. The dependent variable should have a mutually exclusive and exhaustive categories. There should be no multiclinearity. Multiclinearity occurs when you have two or more independent variables that are highly correlated with each other. There needs to be a linear relationship between any continuous independent variable and the logit transformation of the dependent variable, because multinomial logistic regression relies on the logit transformation. And once again, there should be no outliers, high leverage values, or highly influential points.